remind the rest. Okay, now this one we will learn in chapter 6, yeah, but I just go through a quick one today. So sine x is the basic graph. The basic graph is such that, now always, because our quadrant, right, is covered from a 0, then one whole turn, 360 degree. Okay, correct or not? So we have the quadrant such that 0 to 90, and then 90 to 180. 180 to 270, 270 back to the 0, which is also 360 degree. So when we spread it over the graph, right, we mark down the quadrants. Mark down first. 1, 2, 3, 4. So for the quadrant for sine graph, sine start from small. The smallest that we can go, I mean, not smaller. I would rather use the word, the BM word as CFAR. CFAR means 0. Start with 0. Sine start with 0. So from 0, go, it's like a swing. Go up and down, up and down. So from 0, okay, 0, maximum, 0, minimum, back to 0. Never mind about what is the value of the angle. Just remember, based on my quadrants, I mark down my 4 quadrants. So from 0, maximum, 0, minimum, 0. So it will swing back, and our amplitude, the highest that it can swing, because this is 1, so it is 1 here and -1 here. Then of course we will mark the quadrant later, because this is one complete cycle in 360. One complete cycle in 360. Generally, you will have y equals to a sine bx. The a refer to amplitude. The b refer to number of cycles in 2 pi or 360 degree. So when you see sine x, your a is 1. That's why your amplitude is 1. It swing 1 to the top and 1 to the bottom, -1. Okay? And then the mean will be at 0 lah. Now b is 1. That means 1 cycle. 1 cycle means you have a mountain and a valley in 360. Is that okay? Right? So this is y equals to sine x, the basic graph. Now what if I change? I change y equals to 2 sine x. Okay? 2 sine x is the same graph. 4 quadrants, mark down the 4 quadrants, 0, maximum, 0, minimum, 0. And then because my amplitude is 2, so I mark down, instead of 1 and -1, now is 2 and -2. I can change this to 3. This shape is the same. I can draw the same, the height also. I just change from 2 to 3. 3 and -3. Are you okay? That is the A. Now what if the B change? The A remain as 1. Remember, B represent the number of cycles in 360, which means I will have 2 cycles in 360. 2 cycles. Hey, how to spell cycles? 2 cycles in 360, or 2 pi lah. Unless we use pi. Now, how do we sketch the graph? Always remember the 4 quadrant. Mark down the 4 quadrants. For all the 4 every time for the 4 quadrant, start with sine, start with CFAR, 0, the small number, 0, maximum, 0, minimum, 0. This is 1 cycle. We want 2 cycles. Draw another 4 quadrants. Draw another 4 quadrants, copy paste. Copy paste as in like this, really copy paste. So 0, maximum, 0, minimum, 0. Then join together. Isn't it 2 cycles?
Would that be 720?
Yes, 2 cycle in 360. 2 cycle in 360. Therefore, now you mark down, the amplitude is 1. Yeah? Now you mark down 360 here. Half of it, 180. Half of it, 90. And 270 is here. Do you need to mark down this when you got time? When you don't have time, don't have to mark down. So it's actually based on your shape rather than you control by your angle. I think you find it difficult is because you control by your angle. You want to find out at this angle, what should I mark? No. Actually, it should be 2 cycle, I draw 2 cycle, then only I mark down my angle.
Some
Now,
goes up to like 720 degree.
yes, then we can change accordingly. Let's say the question wants us to draw until 270. We draw the complete one, 360. Then we cancel this one, the one. We can erase one. It's much easier. Rather than you mark down 45 degree, what is that? And then you mark, you plot. Using plotting won't give you, you find it is difficult. Okay? Because you need to know the general shape of this sine graph. Now let me just change a little bit. I will repeat this, okay, when we come to chapter 6. This is just a quick glance. Now, let's say sine 3x. We do the same thing. Okay, remember the 4 quadrants? So I divide by 4 quadrants. I need no limited space, so my marking or the division will be smaller as long as I mark down 4. Okay, my amplitude is 1. Okay, I just need 1 will do. So 0, maximum 0, minimum 0. This is 1 cycle. 1 cycle. 3x means 3 cycle. Okay, let's draw 3 cycle. Repeat. Draw another 4 quadrants. Then 0, maximum 0, minimum 0. Complete it. Another cycle. Okay? So don't be greedy and plot all the x first. No, by cycles, by quadrants. Next, another quadrants. Another set of full quadrants to produce the full cycle. 0, maximum 0, minimum 0. Another cycle. So now isn't it 3 cycles? 3 cycles in 360. Now you put 360 here. Then you divide lah. So I have how many division here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you divide by 12 lah. 360 divided by 12. So you have 30 degree here. 30, 60, and then 90. Or we do like this. I got 12, right? So 6 will be my half. So the half is 180 here. How do I get the 120? Because I got 3 cycles, I take 360 divide by 3 cycles. So the full cycle is 120, another 120, another 120. So many ways you can mark down. As I said, I got 12 marking here. I can take 360 divided by 12. Each marking is 30 degree. So I can mark down 30, 60, 90, plus another 30, continue to plus 30, so on and so forth. Okay? 70, and then 300, 330, and 360. What if it is pi? Change lah, you exchange later. Okay, we use 360 easy reference. Now what if sine x plus 1? The basic graph that you draw must be sine x first. Then the whole graph shift 1 unit upwards. So draw sine x first. 4 quadrants. The amplitude is 1. So 0, maximum 0, minimum 0. 1 cycle. This is 1 cycle in 360. So 360, half of it 180, half of 180, 90. So this is 270. The amplitude is 1 and negative 1. Okay, that is only for sine x. I want sine x plus 1. That means every answer plus 1. From 0, you plus 1. Go up by 1 unit. This one go up by 1 unit. So everything, all the graphs shift upwards by 1. So it go up. This is called transformation of graph. Is that okay? Right? And what if sine x modulus? Same thing. Go back to the basic. Then slowly we involve the symbol outside. So we got to draw the sine x first. 4 quadrants. 0, 0, maximum 0, minimum 0 in 360. Okay? So amplitude is 1 and negative 1. 360. Oh, okay. Never mind. I can mark down the 360 first. Modulus means whatever that is negative, shift upwards. Fold it upwards, reflects upwards. So the one that you draw here, you don't need to erase it. Just erase some of the line, make it dotted line. So this will be your modulus sine x graph. Okay, then only you mark down your angle. Okay, sketching one. Sketch, you don't have to be very accurate, but the shape must be there. What is sine x plus 1? Same way you draw your sine x already. the whole graph shift upwards by 1. Go up. All the points go up by 1, right? Then the whole graph go up. Okay? So if you know how to do the sine x, cos x is the same. Cos x is the same. So I won't go through the cos x. Later you can ask. Okay? But the tangent x, the tangent graph, the period is pi over b, but sine and cos graph is 2 pi over b. The b is the number of cycle in pi for tangent, but for sine and cos is number of cycle in 2 pi. That is the only difference. But for me, right, I will see the tangent graph, the complete cycle, I see like this lah. But actually the cycle is this and this. Why do we call it cycle? Before the graph repeat the same pattern itself. So over here you see 2 pattern. But it's very confusing. I say, oh, tangent 1x will be 2 pattern of this. So we make it generalized. One cycle, we take it as, this is to us, it's like 1 cycle. But actually that is 2 cycle. Okay? But for our own understanding, let it be 1 cycle. So if they want us 2x, right? So we shall have 4 quadrant also. Yeah. Yeah, wait. Yeah, it's not here. Alright, let's say it's 2x, yeah? Let's say it's 2x. So I will have 1, 2, 3, 4. I got to draw this one. This one is the asymptote first. So I got to draw this, this, and this. And continue. Okay, 1, 2, 1, 2, 3, and 4 is asymptote. Asymptote. So I will continue. This will be my 2x. Okay, this will be my 2x. So how many cycles is in 2x? 4 cycle. 1, 2, 3, 4. But don't want to confuse ourselves with that. Just remember the basic graph that we see for tangent is this. So our 1x is like this. 2x will be double of this. That's all. They won't find a shifting maybe lah. The modulus will be like this lah. The modulus will be going up like this. Okay, so I will come to this later, right? Because your friend got exam, so we have to cover that in a very quick way. Now, so let's go back to our own pace. Wait a minute. Your exam is until... Okay, our integration done, yeah? Did you try the question? Question 14. Here. Did you find the area of the shaded region for each of the shape here? Did you try? Any question? Maybe I want to cover this. This one, do you see that you have the area below the x-axis? You have to separate this. Okay, you cannot just do integration even though the graph is connected, right? So you have to find what is this, what is the boundary here. The boundary here is 3, and what is the boundary here? Do you see that this graph is x bracket x minus 4? That means you know that this is 0 here and this is 4. Because at x-axis, y equals to 0. Okay, therefore, the x bracket x minus 4 is 0. So it's either x equals to 0 or x equals to 4. Yeah, okay. But then not enough. I need to see what is this. How? So, do you see this line here? This is when your y equals to 5. So when y equals to 5, that means this curve, x squared minus 4x equals to 5 at this point here. So that I can find my x. Are you okay? Because you have one of the value of x, of y. X you don't know, but y is 5. X you don't know, but the y is 5. You know one of the coordinates, you put into the equation. And I expand the equation at the same time. x squared minus 4x equals to 5. You want to solve the quadratic equation, you have to write it in general form. Okay? And therefore you factorize 1 and 5, negative and positive equals to 0. And therefore x is either equals to -1 or x equals to 5. Make sense? Yes. You see the one here, it's towards the right side, more towards the right side. Whereby the one on the left is very near to the 0. So makes sense lah. Okay? So we have the boundary -1 to 0, 0 to 3, and then 4 to 5. You get that first because the area is towards the x-axis. So when the area is towards the x-axis, anything below is negative, you have to find the positive of it. So therefore the area of shaded region, it will be integration of -1 to 0 towards the x-axis. So your subject is the curve, yeah, is the curve. So the subject will be y dx. So what is the y? Y is x squared minus 4x. And then plus the integration from 0 to 3, but with the modulus. X squared minus 4x dx. And plus from 4 to 5. X squared minus 4x dx. You can do separately or you can put everything in the equation. Up to you. Right? So now the next thing is we have to integrate this. So x to the power of 3 over 3 minus 4x squared over 2. Okay, 4x squared over 2, which is 2x squared lah. 2x squared. Because if you differentiate, you bring the 2 down, you get back 4x. And then your boundary is -1, 0. And then plus modulus, you gotta be careful. Now copy x cubed over 3 minus 2x squared from 0 to 3 plus x cubed over 3 minus 2x squared from 4 to 5. Now shows the substitution. 0 to the power of 3 over 3 minus 2 times 0 squared minus the lower boundary. So -1 to the power of 3 over 3 minus 2 times -1 squared. So you got to use the square bracket, yeah? Now this is for the first part. This one tests your patience. Really tests your patience. Okay? Now if you are impatient when the calculation or the working seems to be so many lines, so many things to write, then I would suggest you separate them. You do one by one. Do this one first, then you do this one, but you must remember to add them together. You separate them. Then maybe you will not be so impatient or agitated. Because some of students, they feel agitated when the working is so long, too many things. So you must know where your strength and where your weakness is. If your weakness is being patient, okay, your weakness is being patient. Your weakness is impatience, then you separate it. Okay? If you are okay, can tahan, then you do like this. Okay? So substitution. 3 to the power of 3 over 3 minus 2 times 3 squared. Okay. Then minus 0 cubed over 3 minus 2 times 0 squared. I know it's 0, but better show the marker that you are substituting into the function. Right? The very troublesome one, okay? I do not know what's in your mind. So this one will be x 5 cubed, yeah? 5 cubed over 3 minus 2, 5 squared got to minus, yeah? Bracket in bracket. I have to use the cursive bracket. Okay, and then we have 4 cubed over 3 minus 2 times 4 squared. Okay. Next, calculator lah. Let the calculator do the job. Okay, this is where we can depend on calculator. Right, how? Integrate, key in the original, x squared minus 4x, yeah? So x squared minus 4x, comma, okay, put the boundary in, negative 1 to 0. Negative 1, comma, 0. Okay, so we have, write the fraction form, yeah? 2 and 1/3. So we have 2 and 1/3 here, plus modulus. Okay, so the same function, but I got to change my boundary. So it's from 0, comma, 3. Okay, the rest I got to erase it. Yep. So I got negative 9. Double check, x squared minus 4x. Alright, the boundary 0 to 3. I got negative 9. Correct. So just write negative 9 here. And then plus the next one. Same function. Right, but it's from 4 to 5. So put in 4. And then 5. It's 2 and 1/3. 2 and 1/3. Now you can use the calculator. Alright, 2 and 1/3 plus the 9 plus the 2 and 1/3. So we have 13 and 2/3 unit square. That's it. Minus away the small triangle. No need, because I already integrate from here to here. So I didn't involve here. It's not a triangle anyway, it's a curve. So I only take the part that we integrate. Now for SPM, right, because they need to see you substitute the boundary in. So after that, do you need to show, oh, it is actually negative 1 over 3 plus 2? No need. Okay, because they expect this can be found using the calculator. So actually, when we reach here, we use the calculator and let the calculator do the calculation for us. They don't know. They thought you are using calculator doing it manually. Okay? After all, no marks for the detail working in between. But there is mark for substitution of the upper boundary minus away the lower boundary. Is that okay? Okay? So the marks will be given for your correct integration, and either one they will see, okay, you sub in but upper boundary, lower boundary, 1 mark here, and the final answer 1 mark. So you must know when we use the calculator, what is that we need to write. Okay, we need to write this for sure. This one, because easy calculation, because of different boundaries, so we have to show this. Even though it's not given marks, but we have to show this to fool the marker that we are actually using calculator to do the calculation. You understand? Okay? Right. So this is B. Any more? Oh, only this until B, right? Okay. Now let's continue with find the area bounded by the curve and the horizontal lines and the y-axis. It's actually the same as number 14, but it is towards the y-axis. So when it is towards the y-axis, we shall integrate dy, because when we shade this way, if it is towards the x-axis, you will see that the shaded region is towards the x-axis like this. So you must be able to identify, yeah? Right, if it is towards the y-axis, your boundary must be the y-axis. So it's very obvious here, it's 1 to 4. And the shaded region is on the right side of your y-axis. So it will be positive. So we do not need to create the modulus. So if towards the y, your subject must be x. So you have to make x in terms of y. So this is not x in terms of y yet, so we have to change on our own. So 3x equals to y squared minus 1. Therefore x equals to y squared minus 1 over 3. Put this one in here. From 1 to 4, y squared minus 1 over 3 dy. Now to avoid confusion, the number actually can take out because it will not affect our integration. So we can take the coefficient outside so that it's easier for us to do the integration. Otherwise, you want to divide, 3 over 3, but then there is another 3 down there, so it's kind of confusing. So we try to avoid any possibility that will create confusion. So now we can integrate. So y squared will become y cubed over 3 minus y. Lower boundary 1, upper boundary 4. And shows the substitution. 4 cubed over 3 minus 4 minus 1 cubed over 3 minus 1. Yeah, you gotta show 1 cube, even though 1 cube is 1. But IGCSE, they are not so strict on that. SPM very strict. So need to keep reminding you, yeah. Then after that, once you reach here, already substitute. Okay, once you reach here, you integrate lah. Okay, the integration. Because I just want to do the inside, so I will just take y squared minus 1 lah. The 1/3 is still outside, so y squared minus 1. But don't key in y squared. Our calculator only recognize x, so you have to do the auto replacement. Whenever you see the y, you replace with the x. Okay, so x squared minus 1. X squared minus 1. The 1 over 3 we put outside. Okay, because our substitution also never involved the 1 over 3. So, comma, from 1 to 4. Okay, it's 18. So, therefore, 1 over 3 times 18, the answer is 6 units squared. Is that okay? Right. So towards the y-axis, because you have left-hand side and right-hand side, so you have to understand the left side part. You got to put the modulus for the left side. Okay, left side area lah. Okay, which is from 0 to 1. Whereas this one, from lower boundary to upper boundary, -1 to 0 onto your x dy. Okay, I better do like this. Modulus from 0 to 1 x dy. Or you swap the positioning lah, also can. It's alright. Okay? So I won't go in depth. You should do it by yourself. This one, I think you should know lah. Okay, let us move on. Now, number 16, it's more than one graph. More than one graph, yeah. So I have a curve and a straight line. So I want to find the shaded region. Now for this one, if this is the curve, if I go straight down to the x-axis, I should have the white color part inclusive. But I don't want the white color part. So isn't it white color part is the triangle? So I have to minus it. So you shall use the upper graph minus the lower graph. because they have the same boundary from 0 to, I do not know what is this, but at this point your y equals to x. So I have to solve the equation simultaneously to find the point of intersection. I do know that this is 4, okay, and this is 0. So I got to find that lah. So at this point A, let's call it A. At A, the y, what should I write? The y1 equals to y2. Let the upper one call y1, the lower one call y2. Okay, always take the upper one minus the lower one. So y1 equals to y2. So y1 is x of 4x minus x squared equals to the y2 is x, right? So combine, but make sure your x squared is on the positive, having the positive coefficient. So I shall bring this over the other side. So positive x squared minus 4x plus x. So it becomes positive x squared minus 3x equals to 0. Okay? Yeah, you plus x squared here minus 4x. So x squared minus 3x. Then you factorize is x minus 3 equals to 0. X squared minus 3x. So it's either x equals to 0 or x equals to 3. So I know that this is 3. Okay, now our area of shaded region will be from 0 to 3. You shall take the y1 minus the y2 with respect to the x-axis. No need to do separately, just combine the function will do. So what is y1? y1 is 4x minus x squared. And what is y2? y2 is x, so minus x dx. And therefore, no rush to integration yet until we get everything ready. Okay. Now it's already simplified. Group the like term already. Now we integrate. So we will have 3x squared over 2 minus x cubed over 3 with the boundary 0 to 3. 0 to 3, Yep, correct. Then sub in. Right, 3 times 3 squared over 2 minus 3 cubed over 3. Same function minus away with the lower boundary substitution. 0 squared over 2 minus 0 cubed over 3. 27 divided by 2 minus 9. Nine over 2. Otherwise, use calculator. Okay, use the integration function onto the 3x minus x squared. 3x minus x squared. Right, the lower boundary is 0, upper boundary is 3. Okay, 4.5, which is 9.9 over 2 lo. Okay, 9 over 2 units square. You want to change to 4.5? Also can, up to you. Because this one here is fraction, right? So I leave my answer in fraction. Okay, you must know how to confuse the marker, right? Because the moment you write 4.5, I know you are using calculator. Okay, it's not wrong but the question like just now, the 2/3 things, if you use calculator, it will become 2.33. 2.3333. Always remember, try to leave our answer as exact as possible. No rounding off. Okay. What about this question? So you have to decide, shall I go towards the x or go towards the y? If go towards the y, you must have your x as the subject. But you have the x cubed here. So it's not advisable to make x the subject. So we shall shade towards the y. When you shade towards the y, you need to know what is this part. Because for this curve, it's only start from here to 6. So you need to find out what is this. So at this point, right, You do not know what is your x, but you do know the y value is 4. Okay, so you shall sub x4 into the function. So whenever you see y, you replace with 4. Whenever you see x, just leave it plus 1. And therefore, plus 1 go over. So 4 minus 1 is 3. So 3 equals to 3 over x cubed. So swap the position. X cubed equals to 1. Therefore, x equals to 1. So we found here to be 1. Right? So now let's find the area shaded region, yeah? So the area of shaded region will be this one, right? You can use y equals to 4 to integrate, or actually no need. Isn't it this is a rectangle? Just take the area of rectangle. Okay, area of the rectangle plus integration of the curve. So from 1 to 6 towards the x-axis with the subject y. So I'm going to do the integration, yeah? So I shall write in the format of integration. Right, 3x to the power negative 3 and then plus 1. So the area of rectangle will be the length times the width. So 4 times 1 plus 3x minus 3, okay, plus 1 to the power divided by the new power, and then plus x from 1 to 6. So we have 4 here. Okay, let's settle this part before we substitute. I see the negative here. I don't like it. I don't like negative to be in front. Okay, that's my personal preference. If you don't feel anything, it's fine. I will rewrite x minus 3 over 2x squared. Because x to the power negative 2 is, you bring it down, x squared at the bottom lah. So 1 to 6. Show substitution. So 6 minus 3 over 2 times 6 squared. Minus away the same function, 1 minus 3 over 2 times 1 squared. Okay, let the calculator do the job. Now, how do we key in? What to key in? 3 over x cubed, isn't it? Your y is 3 over x cubed. So when you key in, you got to be careful, yeah? So it is 3 over x cubed. Okay. And then the whole thing plus 1. Plus 1. The lower boundary is 1. Upper boundary is 6. Okay, we have this. See whether it can change or not. Cannot change, huh? So that's it. 6.4583. 6.4583. But is there any way that we can make it simpler? Okay, never mind. Just use this one first. So 4 plus 6.4583. Huh? So we have 10.4583. Just let it be. Now, if you already know how to calculate without, no need the calculator to do the integration for us, then we use this law. Okay, we use this one. 6 minus 3 over 2 times 36. 2 times 36. Okay, and then I have to minus bracket 1 minus 3 over 2. Close bracket. 6 and 11 over 24. 6 and 11 over 24. Double check if that is 6.4583. Yeah, 6.4583. But why I cannot change it back? I don't know. Maybe I need to be not sure. But decimal okay. Either you write this or you write that. So if you write this, your final answer will be 10 and 11 over 24. Either one lah. Either one. So actually you know how to integrate. And you know the application of integration is finding the area. The skill here is more to what are the graph involved. So only from here to here, so only the curve. Shape the curve towards this area, give me this. What about this one? It's a rectangle. So you must identify the shape there. So not all the time, I integrate from 0 to 6. No. You have to see where is the boundary that you cut. Clear? Right. What about this? Same thing, yeah? Because this one we have to go towards the y-axis. Okay? Wait. Since it's towards the y-axis, which means this straight line, if I shape towards the y-axis, I'll get the triangle, right angle triangle, isn't it? I'll get this. And then this part, so you need to see whether the shaded region is by the same curve or different curve. So over here is the curve. Over here is the straight line. This one you can use the right angle triangle method to find lah. Okay, the geometry method. Whereas the curve one you got to integrate. But what is this point intersection here, the y value? So let's say at point, you look at this one. Look at this one first, yeah? At y-axis, x equals to 0. So when x equals to 0, your y and y minus 6 equals to 0. So either your y equals to 0 or your y equals to 6. So here is 0, and therefore this is 6 here. Is that alright? Then what about this? At this point A, at A, the x, the y1 equals to y2, or the x1 equals to x2. Okay, so what is the x1? I let the x1 be the curve lah. The x2 is the straight line. So the x1 part you replace with y squared minus 6y. The x2 parts, yeah, is not y, because you got to bring the plus 6 over. So x2 equals to y minus 6. So you shall replace that and rearrange. Y squared minus the y over minus 7y plus 6 equals to 0. So y wait a minute. Y squared minus 6y, and then x is y minus 6. So plus 6. 6 and 1. 6 and 1. Negative, negative. Therefore, y equals to 6, y equals to 1. Yeah, correct lah. The point intersection between the straight line and the curve is 6 and 1. So now I know the base here is 5. Alamak, if I want to use the geometry, I need to know what is the value of x here. So maybe it's not the idea, not a good idea. I shall use the integration instead. Understand? Right? So if I use integration, I don't have to care about the x value. I just care about the y value. So it will be, now this is the triangle part. You got to plus with the curve part. So two parts, yeah? So for the triangle part, it's because you shape this straight line towards the y-axis. So for this straight line, it is y equals to x squared plus 6, yeah? But because it's towards the y-axis, your subject must be x. So x is y minus 6. So therefore, it is y minus 6. Are you okay? Right? And then from what to what? From 1 to 6. For the curve part, is from 0 to 1 of the curve. The function of the curve is already written in as x as a subject. So it's y squared minus 6y dy. It's impossible for me to combine these two because they are not under the same curve. This part is under the straight line. This part is under the curve. This part, use that other color. This part is under the curve. The yellow part is under the straight line. Okay? And then because both of them are on the left side of the y-axis, so each of them you gotta modulus it. You gotta modulus it, each of them. And therefore, we have y squared over 2 minus 6y from 1 to 6 with the modulus plus y cubed over 3 minus 3y squared from 0 to 1 and with the modulus. Okay, then you show substitution, shows the calculation, then you should be able to get the answer. Is that alright? So you do and you check the answer at the back. You cannot get the answer, then you come back to me. Alright? You complete yourself. Now I want to cover the last part of integration, that is generate the volume. So your exam until chapter 4? Until chapter 2 only. Oh, so we got, alright. Later we can do the revision, yeah? But before that, wait. The Raya, right? Need to discuss. Alani, are you there? Okay, you are here. Okay, we look at this calendar. Now, Raya is on which day? Tentatively is 21st lah, correct? But the school holidays start from 18, correct? Correct, okay? Now, over here, the 20th. Now, let's say the Raya is on 20th. Then 20th, we don't have class. Okay? But if the Raya is on 21st, the first day of Raya is 21st, yeah? Hey, sorry, yeah? We must have class here. But Alani, you need to go back. Balik kampung, right? Your mom said you need to, need to travel or what? Do you think you can do it online? You cannot come physical, never mind. Can you do it online? Or maybe some of you, balik kampung, you cannot come physical, and then we do online. But I think most likely I will be here lah. I won't be going anywhere. If I go somewhere, I will let you know. So if Raya 21st, 20th, class continue. But if Raya is on 20th, then we don't have class here. Okay, we don't have class here. But 27 definitely class is on. If you haven't come back here, you can go online. Okay, but the class must go on. Now, let's say 20th, we don't have class. Yeah, let's say. Do we have 5 Fridays one? They all are 4 Fridays. All 4 Fridays. This one is small. In October, but too long already, too far away. 1, 2, 3, 4, 5. Okay, never mind. My point is, in October we have 5 Fridays, so we can compensate it. My point is, if 20th is Raya, then no choice. We have to go holiday, okay? But if not, 21st is Raya, 20th the class will be on. If you cannot come physical, then online. I will inform you if I cannot be physical. But most likely I won't go anywhere. I don't know yet. So mark it down. Okay? So Alani, is that okay? Like that? The arrangement? I think your mom said if cannot, then you watch the recording. If 20th is not Raya, but you are on your way back to somewhere else, so then you go on, either you go online or you watch the recording. Okay? Alright, so that is our agreement.
Mine's this one.
Which one? Here, your answer is wrong. Let me see.
The right angle triangle.
If you are using the triangle, okay, let me see your substitution. Is it correct? 1. Why is your x is 7? When your y is 1, isn't it your x is negative 5? Isn't it here is negative 5? Correct or not? You substitute y equals to 1 into the function. Here, you substitute here. This is 1, right? Yeah, so when y equals to 1, what is the x? So it will be 1 equals to x plus 6. So x equals to negative 5. So it should be 5 here. Therefore, the height is 5. The base is 5. So with that, do you think you can get the answer? Okay, you'll check on your own. Right, let me just move on with the... Where is it? I forgot what I want. Oh, okay, integration. Hey, your first exam covering Form 4 also? Oh, okay. Okay, we got time, Okay, the integration. Okay. So for the integration, we have covered indefinite integral with the plus c at the back. And with the definite integral, what we have been doing just now was definite integral with the boundary. When there's boundary, we do not need to put plus c at the back. Then after that, the application part, we already covered how to use it for finding the equation of the curve. Okay, use this graph to lead you what you have, and then you move on and then get the corresponding value, so that you can finally lead you to find the curve of the function of the curve. Then we covered this area under the graph. Now we should cover the volume of revolution. Okay, let's look at this. Oh, we got application 3A, 3B. Okay, it's basically is towards the x-axis or y-axis lah. Now the question is like this. I mean the idea is like this. You have this curve. You have this curve from here to here. It's a curve. Actually, don't want to use the curve first. I use the straight line. Okay, the straight line. Let's say here. Now you're going to revolve. You're going to revolve this straight line. Let's say y equals to 5. Okay, from the boundary, let's say this is 1 and this is 4. I'm going to revolve this about the x-axis. That means you imagine there is one piece of things here, like a paper, and now you go down and go about 360 degrees about the x-axis. That means this one, when you flip this paper, you imagine there's a piece of paper here, you flip it downwards, isn't it this y equals to 5 will reach here? Y equals to negative 5. That means this height here is 5. Correct? And because it's the motion that, okay, it's a motion, so can I just draw like that? So when you turn to the bottom part, 180 degree, it will form actually a half cylinder. Can you see that? Then this piece of paper, I flip over about the x-axis, so I will get this one come back here. So now it become a complete what? Cylinder. Correct? How do you find the volume of cylinder? The volume of cylinder, how do you find? What is the formula? No, it's a uniform cross section, so no 1/3 is involved. 1/3 is involved when it is not uniform, from big to small, like cone shape. Cone shape, you have 1/3. Because why? Because it's actually cone is actually coming from the cylinder. Okay, we dig out all this we take out all this. So from the center, we take away the excess block of the wood. What is left behind is only 1/3 of your pi r square h. This is the volume of cylinder. Okay, that is the reason for 1/3. When your shape is getting smaller and smaller until you get a point. Same thing goes to the pyramid, and same thing goes to the sphere. You will have the element of 1/3 there, so 4/3 pi r cubed. Okay, but for uniform cross section, no 1/3 is involved. So the volume of cylinder is pi r square h. Correct? What is the h and what is the r? R, isn't it, is the 5. The r is 5 here. And what is the height? Isn't it, this is the height? From 1 to 4, this is the height. Right? The height is 4 minus 1, which is 3. Correct? Okay, now I want to relate this with the formula here. The volume that we generate this shape towards the x-axis. Now you know how this this sort of like bucket. Okay, how do we get to this? That means any shape that I give you, right, I will reflect it exactly the same, because I flip it around, so actually it creates a motion of this. So I will have this, a bucket. I call it a bucket. Can you see that? Right, that's how you get the 3D shape out from the revolution. Okay, understand, yeah? Okay, now let's go back to the calculation. So isn't it, the calculation will be such that pi must be involved. Why is pi involved? Because we have a circular shape here. For all the circular shape, we will have pi involved. So the formula to find the volume generated will be pi y square dx. If you are towards the x-axis, your subject must be y squared. If it is towards the y-axis, the other way around, let's say it's like this, I go about the y-axis, so it will be like that. Oh, sorry, so ugly. So the volume will be pi towards the y-axis, subject must be x squared. Okay, now then your boundary is from A to B. From A to B of y squared. Isn't it this y squared? It will give you, after I integrate, it will give me, after I integrate, it will give me y cubed over 3 from A to B. Isn't it, you take B minus A? When you take B minus A, it is the height. And you square the one in the of the y, is actually your r squared. So you relate like this lah. Okay? You relate like this, and therefore, in short, the formula will be, if it is towards the x-axis, then it will be pi y squared dx. The boundary is on the x-axis. If it is towards the y-axis, alright, if it is towards the y-axis like this, then the boundary will be on the y-axis. So pi dy, the subject is x squared. Just remember this. X, subject is y squared. If it is towards y, subject is x squared. Why is it square? Because of the cylinder, when we find the r got to be square. Okay, we need to square the r. So the square here basically is this, as though as it is pi r squared. So we have the pi r square h. The h comes from the boundary. Okay? Now, let's look at this question. Every time when you integrate, right, it's a generation 360 degree. Okay? Every time we integrate, go back to this, it means 360 degree. If it is 180 degree, which means you only get this part, semicircular. You only get this part. So your integration, right? After you got the answer, you got to divide by 2. You need to divide by 2. And another scenario, if the curve is like this. The shaded region, the shaded region is like this. Let me think first. It's more on this one, yeah. Okay. Let's say it's like this. Okay, the graph is like this. It's a straight line, it's a straight line. And then I have a shaded region. The shaded region is like this. Okay, when I say I revolve about the y-axis 360 degree, okay, then 360 degree basically is, if you shake this, if you turn this one, from here it will come to here, and from here it will come to here. Can see it now? That is when at this point you only spin 180 degree, you know. This one spin another time. So actually 180 degree, you already get a full 360 degree. Okay? But what if 360 degree, well, it's spin 2 times, it is still the same volume after all. No need to divide by 2. Okay, no need to divide by 2, yeah? But if they want, normally they will say, take this one, only this part. Okay, then you revolve, you want to get back the same cylinder, you got to revolve 360. If you revolve 180 degree only, then you got to divide by 2. Do you understand? Come again, Okay. You may not get what I want to say. Okay, I have a curve, straight line. Use straight line, it's much easier to see. So if it is like this, and I only take this part, I only take this shaded region, and it revolves about the y-axis of 180 degree. The question will mention how many degree that it will revolve about the y-axis. If it is 180 degree, this part, this point here, it will move to here. This point will move to here. So you will actually form a half cylinder. So your integration V equals to pi. This is A, this is B. A to B of dy with x squared. This usually refer to the whole term, 360. But you look at this diagram, I didn't get a whole term. And it say 180. So I got to divide by 2. Okay? But if the graph is like this, okay, I use different color. If the graph is like this, the shaded region is this one. Okay, symmetrical, yeah? Then I say it revolves about 180 degree. So this point will come here. I use different color. This point will come here. And this point will come here, right? 180 degree already, correct? Yeah? So you have this part. But don't forget, as you spin about the y-axis, this side, just now the one I'm talking about is this side, huh? This side will come to here, right? Will come to here. But don't forget, I still have this side. I still have this side that at the same time it will turn another 180 degree. So even though I say it revolves about 180 degree, because it got 2 sides, you turn like this. I just need one side to cover 180 degree, the other side cover another 180 degree, it will be full 360. So for this question, your V remain as pi x squared dy. Are you okay? Can see? Right? Unless I only take only this part 180 degree, then I got to divide by 2. If I take both sides spin at the same time, 180 is enough to get me a full cycle. But what if I didn't say 180 degree, I say 360 degree? then this one will go full. Either this side and this side also go full. Then it's as though as you're taking 720 degree. Okay, but anyway, no matter how many times it turn, it is still remain the same shape of volume. So you don't have to divide by 2, you don't have to times 2. It is just the shape by itself, even though it's spin many times. You see this one, right? This is the axis, right? So if I turn 180 degree, it will be like this. Okay, can you imagine this side cover to this side, at the same time this side also cover, so it's a full cycle, right? But then if I say I want it to be 360, so it continue, but the shape we already got the shape here. It continue multiple times also, the volume is still maintained the same. Okay, this volume, you come here, okay, you spin 180 degree already. The other side also create another semicircle, the other side, a semi-cylinder, the other side. So even you continue to spin one more round, no new volume will be generated. It's the same volume after all. So no need to times 2. Just the volume as it is. Is that okay? Alright? Okay. So let's look at this question. Find the volume generated when the shaded region is rotated 360 degree about the x-axis. About the x-axis. So our formula, volume pi towards the x-axis, subject must be y squared. So the boundary must be x1 and x2. So do we have? Yes, 1 and 2. Can I write y squared in x? My y is x squared plus 1. So let's put it in. The y is x squared plus 1. Don't forget the whole y, you gotta square it. One more time. Must square. Okay, a lot of students, they forgot to square because they thought that, hey, I already see x squared here, so it's already squared. No. It's the whole y that we need to square. Okay? So be careful. Now, before I can integrate, I got to expand inside first, because integration, we can integrate anything, any power of the linear. It must be linear inside. If it is non-linear, sorry, we don't know how to integrate. So for this one, no choice, we got to expand it. So pi. So I haven't integrated, yeah? So the sign, the symbol of integration still there. So we have x to the power of 4 plus 2x squared plus 1. Okay? Square of the first term plus 2 times x squared times 1. Yeah, 2 times a times b. And then plus square the second term. Okay? Now everything's ready. Integrate. So we have pi x to the power of 5 over 5 plus 2x cubed over 3 plus x. Make sure your 5 and 3 is written clearly. Some students, they write their 3 like that. Their 5 also, I don't know how they write. Okay, 3 they write like that. 5 they write like that. Okay? And sometimes when it's too fast, this is 3 and this is 5. Only the writer know what is he writing. The marker won't know. And sometimes when the student, they are under the high pressure during the exam, they themselves also see wrongly. So make sure your 3, you write properly. Really, you got to write properly. Handwriting is very important. Okay? Handwriting is important. So now we do the substitution. Okay? Oh, I need the space here. Okay, let me just put it here. And my volume will be still no space. Okay, never mind. Pi. So 2 to the power of 5 over 5 plus 2 times 2 to the power of 3 over 3. Okay, and then plus 2. Minus the same function but with 1 in. 1 to the power of 5 over 5 plus 2 times 1 to the power of 3 over 3 plus 1. Yeah, don't forget, put a bracket here. Okay, and the big bracket, because the whole thing must attach with the pi later. So now use the calculator. Integration. Key in the original. X to the power 4 plus 2x squared plus 1. So x to the power of 4, x to the power of 4 plus 2x squared plus 2x squared and then plus 1. With the boundary, okay, lower boundary 1, upper boundary 2. Okay. 11 and 13 over 15. 11, 13 over 15 pi unit Q. Leave your answer in terms of pi. No need to change it to what, 3.142. No need. Just leave it like this. And you can leave it in mixed number. If you don't like mixed number, you want to make it in improper fraction. 178 over 15. So 178 pi over 15. Can. If you want to change to 11 point something, also can. Okay? Your personal preference lah. I prefer exact value, so I will leave 11 and 13 over 15. Okay? Right? Any question? Easy? Kind of easy, right? Okay. Super easy. What about this? Rotate about the x-axis. Okay, rotate about the x-axis, therefore the volume will be towards the x-axis, so must be pi y square. So your boundary must be x1, x2. So over here is 1 and 4. The y2, okay, it's already y square, yeah? So y square equals to 16 minus x square. Okay, so substitute that. 16 minus x squared dx. Don't put square here anymore, please, because your subject is already y squared, so you gotta be careful. Need to be careful. Then you integrate. Pi 16x minus x cubed over 3 from 1 to 4. And therefore 16 times 4 minus 4 cubed over 3 minus the same function with 1 substituted in, and the whole thing to multiply with the pi later. So actually integration is much easier than the differentiation, isn't it? Integrate 16 minus x squared. Okay, key in the 1 before the integration. Minus x squared. Okay, lower boundary 1, upper boundary 4. 27. So the answer is 27 pi unit cube. That's it. Okay, easy. All right, finish. Okay, more question now. This one, this is the one I'm talking about. Find the volume generated when the shaded region is rotated 360 about the y-axis. This whole thing under this curve, so when it is rotated about the y-axis, you imagine, let this part coming here. So you will have this shape. Okay? I don't know what shape do you call this. So this is the one rotated about the 360. So this whole thing go through 180, go through another 180. So it's a full shape. It's a full shape. So no dividing two, yeah? And therefore it's towards the y-axis. Volume will be pi towards the y-axis, so dy. Subject must be x squared. this line must be clear. And your boundary will be y1 and y2. So my y1 is negative 2, y2 is 2. Okay, right. So what is my x squared? So means x must be your subject, yeah? So therefore x will equals to y squared plus 1. And therefore from negative 2 to 2, my x squared, I only got x. So my x I got to substitute with y squared plus 1, and finally the whole thing squared, dy. Same thing like the previous question, you got to expand. So negative 2 expand first. So we have y to the power 4 plus 2y squared, and then plus 1 dy. Now we have pi y to the power 5 over 5 plus 2y cubed over 3 plus y, with the boundary negative 2 to 2. Okay, substitute. 2 to the power 5 over 5 plus 2 times 2 to the power 3 over 3 plus 2. Minus the same function with negative 2, okay, as the substitution. Okay, calculator. So we have integration of x to the power of 4 plus 2 times x squared plus 1, lower boundary negative 2, upper boundary 2. 27 and 7 over 15. So 27 and 7 over 15 pi unit cube. That's it. Is that your answer? Okay. How many more? Okay. The other part. Okay, now I've finished this one first. Okay, you do.
So what's your fraction? I can't change the fraction.
You can't change your fraction.
Yeah.
You will get, okay, you get this, right?
Yeah, so
Then you press the fraction bar. Kind of. Let me see. Which model is this? 57MS. Is it because you set your... Okay, let me norm. Go hair wire.
yeah. Took a while.
Why 57? Oh, you cannot. Never mind, just leave it in 27.47 pi. But why let me think. Let me see, mine will have that problem or not. Mine is no brand one. Okay, let me see. Integration of x to the power of 4 plus 2x squared plus 1, comma, negative 2 to 2. Okay, mine also take a while. Yours? Did it take a while in your calculator?
Yeah.
Take a while also, Hello, cannot change back. Oh, then this calculator not bad, this one. Alright, your calculator you will get 27.467. Just write that. 27.467 pi unit cube. Just let it be. Okay? What your calculator show, you just show. Okay. Now what if you are not so confident, then you count this manually. Condense matter, but I think this that one is small matter. Okay, doesn't really matter. Okay, what about this? Okay, you try. So it's a volume generated when the shaded region is rotated 360 degrees about the y-axis. So what it will become? It will become, I mean, the curve is not very clear. If the curve is like slightly like that, so you will form a rugby, they say, look like a rugby. Yeah.
So the points 0 and 3.
0 and 3, yes.
But then the graph's not that accurate.
The graph not occur. Yeah. 0 and 3. Pass through the 0, okay? Pass through 0. I want to check whether I have 2025 trial exam paper. Oh, I do. Okay. Okay, so the volume is about the y-axis, so dy, integrate from 0 to 3 on pi, pi must have pi, x squared dy. So x squared, I have x, so I got to square this whole thing. Must square this, yeah? So pi from 0 to 3, y squared minus 3y, the whole thing squared, dy. And we got to expand first before we integrate. So y to the power of 4 minus 6y to the power of 3 plus 9y squared dy. Okay, double check. Y to the power of 4 minus 2 times this 6y cubed plus 9y squared. Okay, next pi. Now we can integrate. Y to the power of 5 over 5 minus 6y to the power of 4 over 4 plus 9y to the power of 3 over 3, and then the boundary from 0 to 9. No hurry to substitute. Always simplify first. So make things much easier later. Okay, simplify. 3 and 2. So we will have pi. Okay, now we can substitute. 3 to the power of 5 over 5 minus 3 over 2 times 3 to the power of 4. And then plus 3 times 3 to the power of 3. And minus the same thing with 0 substituted in. Okay, this whole thing will be multiplied with pi later. And therefore, the calculator, okay, do the job. Integrate x to the power of too many integration symbol. Okay. Sorry. X to the power of 4 minus 6 x cubed plus 9 x squared. Correct, huh? Y to the power 4 minus 6y cubed plus 9y squared. Okay, the lower boundary 0, upper boundary 3. 8.1. So 8.1 pi unit cube. That's it. Is that your answer? Okay, easy. Right. How many application? 3B. Okay, we have 3B. Let me see any more. 3B, 3. Okay. This one is the volume generated bounded by two graphs. Like just now, you got to minus it. So when it is towards the x-axis, you shall take the upper graph minus the lower graph. So you generate it. Put the pi outside. Put the pi outside. Put the pi outside. So if you can combine, you only can combine when they share the same boundary. If they are not the same boundary, you cannot combine. Is that okay? Just like the area. The only thing is got pi, and you got to square your subject. Same thing goes to this, right? Because it's towards the y-axis. So the outer graph minus the inner graph. Okay, so you have pi x1 squared minus pi x2 squared. Okay, put the pi outside. You can only combine them if they share the same boundary. Can? Alright, let's look at this. Find the volume of revolution when the shaded region is rotated 360 about the y-axis, like this. So if it is like this, you shall take the upper one minus this one. Okay? But they are not sharing the same boundary, so you got to split them. So the volume will be pi. Take the upper one. So towards the x-axis, yeah? Now the upper one is this. This one. Which is this. Why the labeling so... Okay, this one, the curve. How do I know? Because this is a quadratic graph, but the opposite. So you have y squared here. So since it's towards the x, so it must be y squared. Always remember y1 squared, and then minus pi, and then towards the x, y2 squared. So you got to define your y1 and y2 clearly. So this is my y2. This is my y1. And for my y1, the boundary is -1 until here. What is this? It's 3, 2. It means the x coordinates is 3 here. The y coordinates here is 2. So it's from -1 to 3. That is my y1. My y2, actually y2 is a straight line, right? So can you imagine when I revolve this, it's actually form a cone. You can use the cone shape. Okay, the cone shape will be 1/3 pi r squared h. We try both to let you see how it works. So we have pi. The y1 squared is this. So my y1 squared, x equals to y1 squared minus 1. My y1 squared will be x plus 1. So pi x plus 1 dx from -1 to 3. Not -1 to 0, yeah? Because the shaded region is from here to here. The shaded region, if you're talking about the shaded region first, and then cut away the white one. So it's the whole thing, including this one. So therefore, our integration is from here to here, so that when you drop, it's a straight line, drop to the x. Okay, so it's -1 to 3 onto my y square, and then minus pi. The y2 square is here, so 3y2 equals to 2x. So the y2 subscript means the second y, so 2 over 3x. So my y2, 2x over 3, you gotta square it dx from 0 to 3. Okay, so we have separate of this, yeah? So x squared plus x squared over 2 plus x from -1 to 3 minus pi. This one will be, we cannot integrate yet. We open up the bracket. We have 4x squared over 9 dx. Okay, over here, sub in. Test your patience now. Once you integrate, right, the rest will be testing your patience. So we have 3 squared over 2 plus 3 and minus -1 squared over 2 plus -1. And then minus, now I integrate this now. I can take out the 4 over 9. I left with the x squared inside, yeah? So integrate the x squared. Okay, never mind. Just, okay, don't want to write so many lines. Alright, so 4x cubed over 9 divided by 3. So from 0 to 3. So over here, use calculator. Don't want to waste time. So for this one, the integration is x plus 1. So integrate x plus 1 for the boundary -1 to 3. It's 8. So we're 8 pi here. Minus this one. Oh, show the substitution. 4 over 27 times 3 to the power of 3, and then minus 4 over 27 times 0 to the power of 3. This one is actually 4 pi. So 8 pi minus 4 pi equals to 4 pi. 4 pi unit square. Okay, because this and this can be simplified. Left with 4 pi. Now what if we know that this whole thing is 4 pi? If I use 1/3 of pi r squared, h, will I get 4 pi as well? So 1/3 of pi. Now the r is the radius of your circle base. So over here it is 2. So your r is 2. So 2 squared. And the height is from here to the tree here. So the height is 3. Simplified. Can you see that? I got 4 pi. So the volume of the cone is 4 pi. Whether I use the geometrical formula or I use the integration, I will definitely get the 4 pi for my integration of the straight line. Is that okay? Right? But when you want to use this, you got to be careful. Which one is your height? Which one is your radius? The radius is the one that formed the circle. Then only we have the radius. Easy? Okay. So I think that's all. You can try all the questions in the workbook. Now, the next class, right, we finish chapter 3. Next class, we shall do, I think, the revision. Can we do the revision? So I will send you this. I'm not sure, have I sent this before? The 2005 trial paper. Did I send before? The one I share with you is 2004, right? 2024, sorry. Yeah, I guess so. Hey, sorry, not MCLC. It's the trial paper. Okay, 2025. Because when you were, yeah lah, correct. When you were in Form 4, I shared with you the one before. So the topical. Yeah. Question. Yeah, I don't think you have seen this before. The one that you have is not this color. Is this? 2025. Right, I will share this. Then you can try the question there. Okay. Right, that's it. Thank you very much. Hey. Okay, stop sharing. Alright, thank you. Later I share the WhatsApp. Okay, bye-bye. Good night. So the tomorrow next week we do revision.